In this example, we have two children playing on a seesaw. We know the distance each one of them is from the fulcrum of the seesaw, and we know the weight of the girl. And the question is, if the seesaw isn't rotating at all, what's the weight of the boy? If the seesaw isn't rotating at all, we know it is in rotational equilibrium, so the sum of the torques on the seesaw is 0. What torques are acting on the seesaw? Well, in reality, there are really 3, but we're only going to consider 2. First, let's look at the girl. Her weight is pushing down 1.30 meters from the fulcrum. That's going to exert a torque, causing the seesaw to rotate counterclockwise. The boy's weight is pushing down on the seesaw at a distance of 1.00 meters from the fulcrum. That's going to exert a torque that's going to try and rotate the seesaw clockwise. Those are the only 2 torques we're going to consider. There is the possibility of a third torque, but we're going to ignore it. That third torque might come from the weight of the seesaw, depending on how the seesaw is made. However, I don't want to go into that much detail. Most likely, the torque exerted by the weight of the seesaw is very small, so we can ignore it.
Okay, so we have 2 torques we're considering here. And since the seesaw is not rotating, we know that the sum of those torques has to equal 0. So we can start this problem by simply determining the torques involved. Let's start with the girl. The girl is trying to get the seesaw to rotate counterclockwise. By convention, we call counterclockwise torques positive. So her torque is positive 201 newtons, her weight, times 1.30 meters, which is the lever arm. When you work those numbers out, you get 261 newton meters. Now let's move on to the boy. The boy is trying to get the seesaw to rotate clockwise. By convention, we call clockwise motion negative. So his torque is going to be negative. Now we don't know his weight, so we'll just call it W. But we do know the lever arm. The lever arm is 1.00 meters. So his torque is simply negative W times 1.00 meters. Okay, now all we have to do is make sure those torques sum up to 0. So we take the girl's torque, 261 newton meters, and we add to it the boy's torque, negative W times 1.00 meters, and that sum has to equal 0.
So now we have an equation with only one variable, W, and we can solve for it.
We add W times 1.00 meters to both sides, and then we divide by 1.00 meters.
And we find that weight is 261 newton meters divided by 1.00 meters. The meters cancel, and we're left with 261 newtons. So the boy's weight is 261 newtons. 261 newtons.